Dear students, welcome to mathematics online classes. Exercise 7.11 we are solving. In that, question number 16. Question number 16 is integrating from 0 to pi log of 1 plus cos x with respect to x. Log of 1 plus cos x with respect to x. Here we using integrating from 0 to a f of x with respect to x is equal to integrating from 0 to a f of a minus x into dx. Okay, this is I is equal to integrating from 0 to pi. Let me take this as equation 1. We have log of 1 plus cos of pi minus x into dx. This is I is equal to integrating from 0 to pi log of 1 log of pi minus cos of pi minus x, 180 minus x. Cos will be negative, so this become 1 minus cos x into dx. Let me take this as equation 2. Yes, adding equation 1 and 2, adding equation 1 and equation 2. Left hand side I have I plus I, 2i, which is equal to right hand side 0 to pi log of 1 plus cos x plus log of 1 minus cos x. Whole integral is with respect to x. See, it is in the form of log m plus log n. Log m plus log n is equal to log of m into n. Yes, 2i is equal to integrating from 0 to pi log of m into n, log of 1 plus cos x into 1 minus cos x into dx. 2i is equal to integrating from 0 to pi log of, you see it is in the form a plus b into a minus b. A plus b into a minus b is a square minus b square, 1 minus of cos square x into dx. 2i is equal to integrating from 0 to pi log of 1 minus cos square means log of sin square x into dx. Log of sin square is in the form of log of m raised to n. It is n into log m according to the formula. We have 2i is equal to integrating from 0 to pi 2 times log of sin x into dx. 2i is equal to 2 is a constant multiple. We can write 2 into integration of log of sin x with respect to x from 0 to pi. 2 to get cancels out. We have I is equal to log of sin x with respect to x from 0 to pi. You see, from here onwards, log of sin x with respect to x from 0 to pi is the same as the example 16. Is same as example 36. Example 36, 0 to pi by 2 is given. Okay, 0 to pi by 2. One more step I have to do here. Which property to use here? We will use property P6. Property P6 is 0 to 2a f of x into dx is equal to 2 times integral from 0 to a f of x into dx if f of 2a minus x is equal to plus f of x. This is 0 if f of 2a minus x is equal to minus f of x. Okay. Here f of x means log of sin x. In place of 2a, pi is there. So f of pi minus x equal to means f of 2a minus x is equal to log of sin of pi minus x. Log of it is log sin x. Pi minus x means 180 degree. Sin of 180 degree minus x. Second quadrant it will be sin only sin x. Log sin x means f of x. Which one is valid here? First case is valid. Means we will write the integral I is equal to here 2 times integrating from 0 to pi by 2 log of sin x into dx. Here you observe from here onwards except this 2. 2 is a constant multiple. This is log of sin x from 0 to pi by 2. This problem is similar to example 36 we solved. Similar to the example 36. From here onwards, you proceed with the same way what we did with that example. Okay. Instead of wasting the time, if I solve that again, it will be solving the same problem again and again. That's why I am leaving it to you only. I will move on to the next problem, problem number 17. Problem number 17 is I is equal to integration of square root of x by square root of x plus square root of a minus x into dx from 0 to a. Very simple problem it is, very simple. Let me use the property using integral from 0 to a f of x into dx is equal to integral from 0 to a f of a minus x into dx. Let me name this as equation 1, and now I is equal to integration of square root of, here 0 to a is there, this become a minus x by square root of a minus x plus square root of, see here it is square root of a minus of, x will become a minus x, a minus of a minus x. This is square root of a minus into plus minus a minus into minus plus x. Plus a minus a get cancel. We have this is root x into dx. Take this as equation 2. I will erase this. Taking equation 1 plus equation 2, we have taking equation 1 plus equation 2, left hand side 2i, right hand side. Why I am taking equation 1 plus equation 2, you know, if you add up, that get cancels out. Square root of x by square root of x plus square root of a minus x, it is from the first equation, and from the second equation it is square root of a minus x by square root of a minus x plus square root of x. Integral is with respect to x. 2i is equal to integrating from 0 to a, denominator you observe, denominator is square root of x plus square root of a minus x, and the numerator is square root of x plus square root of a minus x. Whole integral is with respect to x. These two get cancels out. We have 2i is equal to integrating from 0 to a, integration of 1 with respect to x it is. What is integration of 1 with respect to x? It is 1. 1 from 0 to a. It is a minus 0, nothing but a. 2i is equal to a. What is I is equal to? I is equal to a by 2. This is about problem number 17. Now moving on to problem number 18. 18th problem is integration of mod of x minus 1 with respect to x from 0 to 4. Integration of mod of x minus 1 with respect to x from 0 to 4. Again, modulus function it is. Modulus of x minus 1 is equal to, otherwise let me write the definition. Modulus of x is equal to plus x when x is greater than 0. It is minus x when x is less than 0. In the same way, here I have modulus of x minus 1 is equal to, modulus of x minus 1 is equal to plus of x minus 1 when x minus 1 is greater than or equal to 0. It is minus of x minus 1 when x minus 1 is less than 0. Here I can write plus of x minus 1 when x is greater than or equal to 1. It is minus of x minus 1 when x is less than 1. Here you see we are integrating from 0 to 4. While integrating from 0 to 4, we can't take it as a single function. We should split it into 2. Modulus is there. See, at 1, when x values are less than 1, modulus of x minus 1 should be chosen as minus of x minus 1. When it is from 1 to 4, function is different, that is plus of x minus 1. So, integrating from 0 to 4, we will take it into two integrals. One is 0 to 1, another one is 1 to 4. Yes, 0 to 1, modulus of x minus 1 is minus of x minus 1. You write it is minus of x minus 1 into dx. Next, 1 to 4, modulus of x minus 1 is plus of x minus 1 into dx. This is 0 to 1, minus will get multiplied with these two. We can write here 1 minus x into dx. It is 1 to 4 x minus 1 into dx. Now we will integrate very easily. Integration of 1 with respect to x is x minus of integration of x with respect to x is x square by 2 from 0 to 1 plus integration of x is x square by 2 minus integration of 1 with respect to x is x from 1 to 4. Yes, substituting the upper limit, it is 1 minus 1 by 2 minus of 0 minus 0 by 2 means 0 plus of, here substituting the upper limit, 4 square, that is 16, 16 by 2 minus 4 minus of, substituting the lower limit, 1 by 2 minus 1. Here it is 1 minus half is half plus of 2 ones are 2, 8 are 8 minus 4, 4 minus of cross multiply, this become 1 minus 2 by 2 means minus 1 by 2, minus minus plus 1 by 2, 1 by 2 plus here 8 plus 1 9 by 2, this is 10 by 2, 2 ones are 2 5s are, so answer is 5. Problem number 18 completed with that. Now problem number 19. Problem number 19 is given as show that integration of f of x into z of x with respect to x from 0 to a is equal to 2 times integrating from 0 to a f of x into dx if f and z are defined as f of x is equal to f of a minus x and z of x plus g of a minus x is equal to 4. Okay, very simple, it is very simple one. You see, f of x is equal to f of a minus x, z of x plus g of a minus x is equal to 4. They have a relation, means the functions are related like that. We need to show here integrating from 0 to a f of x into g of x is equal to that 2 times 0 to a, that one we have to show. Okay, let me take it as I is equal to 0 to a f of x into g of x into dx. See, we will use the property here because they have given f of a minus x and all. Using 0 to a f of x into dx is equal to 0 to a f of a minus x into dx. Now we have I is equal to integrating from 0 to a f of a minus x into g of a minus x into dx. Okay, I is equal to 0 to a, f of a minus x means they have given you it as f of x only. You write it. Then what is given g of a minus x is equal to, it is given g of x plus g of x plus g of a minus x is equal to 4, it is given. Then what is g of a minus x is equal to, g of a minus x is equal to 4 minus g of x, taking g of x to the right side. Here I write g of a minus x is equal to 4 minus g of x into dx. I is equal to, integrating from 0 to a, f of x will get multiplied with this 4 times f of x minus of f of x into z of x, whole integral is with respect to x. Okay. Now, I is equal to, integrating from 0 to a, here I will write it as sum of two integrals. First one is integration of 4 into f of x with respect to x from 0 to a. Second one is integration of f of x into z of x with respect to x from 0 to a. I is equal to, from this first integral I will write 4 outside, 4 into integrating from 0 to a f of x into dx minus of, you see 0 to a f of x into dx is nothing but I. Take this I to the left hand side, I plus I become 2i. 2i is equal to 4 times integrating from 0 to a f of x into dx. Here 2 ones are 2 2s are. I is equal to 2 times integrating from 0 to a f of x into dx. Yes. If you take this as equation 1 and this as equation 2, from 1 and 2 we can write, from equation 1 and 2 we can write integrating from 0 to a f of x into z of x with respect to x is equal to 2 times integrating from 0 to a f of x into dx. This is about problem number 19. Now, remaining two problems, those are multiple choice questions. Choose the correct answer. Choose the correct answer. Question number 20, it is given as the value of integration of x cube plus x into cos x plus tan raised to 5x plus 1 into dx, where integration is from minus pi by 2 to plus pi by 2. Option A is 0, option B is 2, option C is pi, option D is 1. It is very simple one. Those who know the properties of definite integrals, it will be easy. See, here I is equal to total sum of 4 functions it is given. I will take sum of 4 integrals. First one is integration of x cube with respect to x from minus pi by 2 to plus pi by 2. Second one is integration of x into cos x with respect to x from minus pi by 2 to plus pi by 2. Third one is integration of tan raised to 5x from minus pi by 2 to plus pi by 2 into dx. And last one is integration of 1 with respect to x from minus pi by 2 to plus pi by 2. See, we know the property P7. Property P7 minus a to a is equal to 2 times 0 to a f of x into dx if it is even, otherwise 0, means if it is odd, 0. X cube is odd function or even function? It is odd function, so directly you write this answer 0. Next, x into cos x is check, if you replace x by minus x, this will be minus x, cos of minus x is plus cos x only. So, we will get minus of f of x. Second one is also 0. Third one, tan raised to 5x, tan raised to 5 of minus x, tan of minus x is minus tan x. Minus is getting multiplied odd number of times, 5 times, again that becomes minus tan raised to 5x only. So, 0. And now last one is that even if you replace x by minus x, f of minus x is equal to plus 1 only, that should be taken as plus f of x only. So, that is even function. As it is even function, we will take it as 2 times integrating from 0 to pi by 2 integration of 1 with respect to x. This is equal to 2 times integration of 1 with respect to x is x, 0 to pi by 2. 2 times it is pi by 2 minus 0 means pi by 2. 2 to get cancels out. Pi, option C correct. This is about problem number 20. Next, problem number 21. Problem number 21. The value of integration of log of 4 plus 3 sin x divided by 4 plus 3 cos x into dx from 0 to pi by 2 is option A 2, option B 3 by 4, option C 0, option D minus 2. Yes. Now, I take I is equal to integration of log of 4 plus 3 sin x by 4 plus 3 cos x into dx from 0 to pi by 2. Let us take this as equation 1. Now, I will use the property using integrating from 0 to a f of x into dx is equal to integrating from 0 to a f of a minus x into dx. I is equal to integrating from 0 to pi by 2 log of 4 plus 3 into, I will write directly here 4 plus 3 into, because these are all MCQ questions, multiple choice questions, we should have that is strong identification, that is sin of pi by 2 minus x. Sin of pi by 2 minus x become cos x divided by 4 plus 3 times cos of pi by 2 minus x is sin x into dx. This is equation 2. Okay, add equation 1 and 2, adding equation 1 and equation 2. Left hand side I have I plus I is equal to 2i, I plus I 2i. Right hand side 0 to pi by 2 is the integral. We have the functions log of 4 plus 3 sin x by 4 plus 3 cos x plus of log of, here it is 4 plus 3 cos x by 4 plus 3 sin x. Whole integral is with respect to x. You see, these two functions are in the form log m plus log n. Log m plus log n is equal to log of m into n. We have 2i is equal to integrating from 0 to pi by 2 log of m into n, log of 4 plus 3 into sin x by 4 plus 3 into cos x is m into n is 4 plus 3 into cos x by 4 plus 3 into sin x. You see, 4 plus 3 into sin x, 4 plus 3 into sin x cancel. 4 plus 3 into cos x, 4 plus 3 into cos x get cancel. We have 2i is equal to integrating from 0 to pi by 2 log 1 into dx. What is the log 1 value? Log 1 to any base is always 0. So, integration of 0 to pi by 2 into 0 it is. 0 into dx, that is 0. 2i is equal to 0, then I is equal to 0. Option C correct. Okay. See, up to this, with this problem number 21 in the exercise 7.11, we are completing with the integrations. What about the miscellaneous part and miscellaneous exercise? From the theory point of view, that part is not at all important, and along with that, we don't have that much time to solve all those problems. You solve on your own. If you have any questions, you are free to ask us. Next, one more thing is that next class onwards, we will take to the next chapter, and if I get enough time, definitely I will upload all the problems of the integrals which are given in miscellaneous examples and miscellaneous exercise. For integrations, this chapter is not such a luxurious chapter. It is not that much easy. I think already you have experienced it. Please repeat the chapter again and again. All those videos will be freely available. Watch them again and again. Watch them again and again and learn well the integration. Thank you.